Good morning and welcome to this workshop on the digital backbone for nuclear plants and projects. So one time I was on the construction site. We were expecting a delivery of piping. The crews were there. The work order, the work packages were there, but the delivery of the material never came through. So we found out that the engineers actually knew that this delivery was not going to be there. It was going to be 3 months late. And what happened? Of course, this delay was very bad, but that was not the worst thing. The worst thing was that this information was in the organization, but on the silos of the organization, this information never made it through to the construction site. So information availability is a must. What we learned on that day is something that I think we all know, right? And that is that our greatest financial risk is not the complexity of the engineering or of the operations, it's the lack of real-time communication between all of the crews that are needed in order to build a plant, to maintain a plant, and to operate a plant. So we in Hexagon think that a digital backbone is not a luxury anymore. This is actually a must in our business. So what is a digital backbone? It is not a big piece of software. It is actually a concept that says that it is the central nervous system where all of the data, the information is flowing from one stakeholder to the other so that everybody has the visibility of information that it needs in order to do its job. And we have divided the asset life cycle of a plant into digital projects and digital assets. And if we talk about the digital project side, we start with portfolio management, project management tools. Then the data goes over into the design part. This is where the engineers are doing the design and engineering of everything, right? Now, this needs a high quality data so that the execution part of the project, so that supply chain, fabrication, and construction can consume this data, do a good job on site, do the construction, commissioning, get all of these activities into the digital backbone, and we can do a proper handover to the digital asset side, where the owners take this data and now can run a safe operations of the plant through operations, maintenance, and security. Now, in order to give 2 concrete examples how we can do this, we have 2 special guests here. The first one is Farid Tata from our dear customer DIAS, working for ITER. He's going to explain how a specific workflow for pipe stress has been improved through this concept. And then after this, we will see how once we have a true digital backbone, we can use this data layer to get some good insights with the digital assets. And for this, our VP of Software Development and Head of App Security will talk about how we can use this to use Gen AI into our operations. So help me welcome Farid Tata.
Is there a laser pointer?
No laser. No?
So, hello everyone. I'm going to present you, as Jorge said, design part of the digital backbone and how the pipe stress new version, the pipe stress 8.0 version, helps us to streamline our workflow and how we can work more efficiently, specifically for piping stress analysis at high temperatures. And it is particularly the case for fusion, SMR, and AMR as well. So the biggest problems we have to solve in high temperature, of course, is the high thermal expansion issues we have, the creep and the fatigue and the creep fatigue issues that appear at these temperatures. We also have to handle some other loads like neutron irradiation and other problems like this. We also have to comply with the codes, the regulatory codes, which is not the case, was not the case for the RCCMRX up to today. So we had to do our own custom tools, which are not that efficient and don't provide the qualification and validation necessity. So we had no tool available on the market to do that. So today I will present you how HEXAGON was able to help us do that for my specific problem, which is for high temperature piping in ITER. I will quickly present what is ITER if you don't have an idea. So the logo that you see is actually a sun. So the idea is to put the sun power into a box. Okay? So it's an international program. It's an experimental reactor involving the whole world. You can see the USA, Russia, China, Japan, who is I'm forgetting, India, of course. So the whole idea is to keep the sun into a box. It's located here. There's a construction site going on today. It's located in South France. You have here a plain view of this work site. And this is where the core is located, what the fusion happens. It looks like this. This is an artist view of what is this reactor. It's a tokamak. You see here in purple, you can see the plasma, where the energy is produced. So in my specific problem is I have to solve this high temperature pipe stress analysis for the TBB, tritium breeding blankets. They were called TBM before. So it is this small area here that we can use to do our work. What is the basic principle of this? We have these tritium breeding blankets. We have to produce tritium, okay? To feed the reaction of fusion, we have to produce these tritium. So the TBB are here for that. But as engineers, you don't need to know what's behind, what the science behind this. You just need to know that it is a very high temperature that we have to deal with. The part in red is where the reaction takes place. This is where we have to cool because it's too hot. So the part in orange, which is circled in orange, is the whole system, the coolant piping system that we're using to cool down this part which is at very high temperature. So in all that, we are dealing with very high constraints in terms of course, temperature and pressure, but as well as we have nuclear classified components. We have also very high imposed displacements. For a mechanical engineer, it's a nightmare. So we have to solve all these problems. This is an example of piping layout that we have done with pipe stress previous version. This is what it looks like. Okay. So all this collaboration or cooperation started back in 2023, because now we are talking about cooperation with HEXAGON. So I'm working for ITER, and I am a DAES employee. So all this started in 2023, where there was the pipe stress days where we joined. It was specifically for specialists, but we met all the executive people of HEXAGON back then. You have the name of the people who were there. So all these people, we kept contact with them. We kept contact, and we continued our collaboration, our contribution to developing the RCCRX for pipe stress. This is a typical software development phase. So you can see here in red, the red dot and the red arrows where we have contributed, we have helped HEXAGON to develop this tool. So this is a concrete example. This is an example of the collaboration that we have done with HEXAGON. So this is dating back to 2023, where we had to check with HEXAGON this G factor. So you may not be aware of that, but the G factor is one very interesting feature of the RCCMRX for high temperature piping. It allows you to reduce, actually to use the inelastic properties of the materials with an elastic calculation. So it has a very interesting feature. So we did the check this with the Irene Cornaton from HEXAGON, who was a main dev for pipe stress. In the top, you have our estimation, our calculation. And in the bottom, you have HEXAGON alpha version, HEXAGON pipe stress alpha version results. You can see that they are exactly the same. So this was very reassuring that our collaboration had a good start, so we could continue. This is another example of continued cooperation we have with HEXAGON, and in this case, the AFSEN, which is, you know, the editor of the RCC MRX, or many other things, but MRX in particular. So this is a benchmark of the same tool, PipeStress 8.0, where HEXAGON, namely Christopher and Tui, proposed us this model, and where we are the assessors. So this is a typical example of continued collaboration with HEXAGON. So now for specialists, why we need MRX, why MRX is useful, and why we need PipeStress. So in short, the MRX has very good features, very interesting features for us engineers. It has this G coefficient that I talked to you earlier. It's a very nice one, very nice feature. It also has a very large database for materials that you can use in irradiated environment and high temperature environments. This is, just for these three advantages, the MRX is very interesting. Now the interest of PipeStress, the software which is implementing the RCC MRX, of course, it's the efficiency. You have to model and you have to run and you get the results. It may look natural, but it's not. So the other very nice feature that the PipeStress offers us is the qualification and the validation of the software. So when you have to present your results or your models to a nuclear authority, it's much serious. You look more serious than presenting just Excel files. And the other good feature is that you have models which are readable, and this is a very important point. It's a key point. If you want to work in the nuclear environment, your models have to be readable. No black box. So, and the other nice feature is that we have 50 years of return-on experience from HEXAGON and PipeStress. So, this is the older workflow. So this is how we used to work before. So you will recognize, for some of you, that we have an initial layout. We have to export this layout to a usable and readable file, readable by PipeStress, of course. Then you have to process it. Then you had to post-process it according to the RCC MRX, because no tool was there available for us. It's the same way for a 3D deformed shape. So I will show you quickly how we did it. So this is the translation from the model, 3D model or CAD model, into something readable by the software. Next, we have to parameter our model. We have to make our brains work and create our load cases. Then we solve it. You can notice in red, it is solving according to MX and not MRX. This is an important point. And in the end, you had to post-process it using Excel files. This is what I was thinking when I told custom tools. This is a typical custom tool. Very advanced one, but yet a custom tool. It's not 100% reliable. When you present this to ASN, you're not 100% satisfied. So what you want to do is to remove this last step. We don't want this last step. So thanks to this new version, we are able to have a much shorter workflow. And you can already see that we have we have the initial layout, the polyline export, and then the processing and post-processing done at the same place by the same soft according to the RCCM RX. So this was a very good achievement. This is a very good achievement. We still have to work on these two first steps to make it even more streamlined, to help us go from modelization to results as quick as possible and as efficiently as possible. But that's already nice to have, very nice to have. So, in conclusion, what we can say is that this new version that is released by HEXAGON, the PipeStress version 8.0, you already have natively the RCCMRX implementation available for you. It is very nice to reduce the time from modelization to results. So the streamlining is perfect. And it can help you to master challenges at high temperatures for fusion and other high temperature reactors, as said, AMR, SMR. So it's one of the first tools to propose that for pipe stress engineering, pipe stress analysis. You can understand now we have one compliance, we have one in accuracy, and we have one in efficiency. So all for that, just for that, it's already very, very nice, nice things that they have developed. So, and now I invite you for the next, after the next step, to join us there in there, so we can do some connections and some more detailed question and answers, if you like. Thank you.
So very specific and nice example how digitalization can improve your workflow. So now let's imagine that the analysis is done, it's flowing to the design tools, it's going to construction, hand over to the client, and now we have a digital backbone that, of course, the plant is changing, right? So we have to manage these changes. We have to ensure that it's always true. And this is what we call the concurrent engineering, so that we can have a stable or a true base of the data of the plant throughout its life cycle. Now, when we ensure that this is all true, now we can build very advanced technologies and really have fun with technology. This is why Julio Roque is here, our VP of Software Development. He's going to talk about Gen AI, how we can leverage all of this data.
Good afternoon, everyone. The digital backbone creates a significant amount of data. So one of the challenges that you have is, how do you use that data? How do you have access to that data? So you can export, you can do reports, you can do all sorts of things. But one of the things that we were trying to do is give you a direct interface to the data in such a way that you could actually have real-time benefits and reduce your time to value. So one of the things that we have done is that we have created a product that is integrated into our products that allows you to query and have direct access to both knowledge, generic knowledge, but also your data, which is, again, a key differentiator that we have, because the data is very significant. One of the benefits of our products is that you can customize it and you can change it to fit your needs. So instead of work orders for repairs, you can have support tickets. Instead of support tickets, you can have activity orders. Everything is different. So how do you train an AI? How do you make an AI? When you search for support tickets, you actually get work orders. And when you search for work orders, you get work orders. So having to normalize this data becomes very difficult from an AI perspective. But before I go into what we did, let's make sure that we are on the same plate, because everybody has a different idea what AI is and what Gen AI is. Not everybody really fully agrees in what it is. So I'm going to give you a small briefing of what we consider AI. And AI is not new. People consider this to be brand new. We've been doing neural networks for the last 50 years. But what we consider AI today, or Gen AI, really was revolutionized by a paper done by Google and the University of Toronto called Attention is All You Need. This is the beginning of the transformer architecture, which is the foundation to every single AI product that you have in the market today. There are different models, there are different ways. You have one side or the other, input, output, but everything is based on this paper. This seminal paper created the entire revolution that you have today. So when you are acting ChatGPT or Claude, this is what you're using. Now, the transformation part of this is that now you could actually have what they call sentiments, and you can have different understandings of what the data is, so you can look at the data as a whole instead of individual words. The problem with this is that they're very expensive. Extremely expensive, not only in computational, but also in energy, also in resources, because the foundation of this is all based on your data. Just getting the data in a way that you can use it is extremely difficult, extremely expensive. So being able to train AIs, to get a blank AI and connect it to the internet and train it completely becomes very expensive. That's what Google did with Gemini Ultra, which is, again, a few years old. Now the numbers are in the hundreds of millions of dollars to be able to train an AI. So we looked at different ways to be able to do this. And there are three basic ways that you can train AI. You can do the basic training that I tell you about. You get a transformer architecture that you can go to the internet and download it. You connect it to a data source and train using the transformer architecture to create the statistical model that is what Gen AI is. It's a very sophisticated statistical model. It's not the internet. I'm sorry, it's not the Star Trek computer. It's not HAL 9000. It is literally a sophisticated statistical model. That's the basic training. It's extremely expensive. The next thing that you can do is that you can get a model that has been trained already. You can take it and download it. There are a number of public sources models that you can take. Mistral from a French company is an extremely good one. You can get Meta from Llama 4 from Meta. You can get DeepSeek. You can get Gwen on the Chinese side. Very good models. And you can fine-tune it. Fine-tuning is where you go to the statistical token and you can adjust the weight of that token to get what you want. Seems easy. Again, data comes into play. For you to adjust one single word in a model takes 2,000 questions and answer pairs so the model can understand what you mean. So if I want to change HEXAGON EAM to Octave EAM, I need to put together 2,000 questions and answer pair that I can feed to the model for the model to understand that now it's not Hexagon, now it's Octave. It's easy. It's only literally 2 pages of Python code, extremely easy coding, but the data is significant. And of course, the computational power that you have to feed it for the model to run. The next one, the third one, which is really used for enterprise, and I'm going to tell you a little bit about it, is called RAG, Retrieval Augmented Generation. That's where you get all your documentation, you get all your data, you put it on a vector database, which is the three-dimensional view of your data, and you're able to search it, you're able to retrieve it, hence the name, and you're able to generate answers. It has its own difficulties, its own uniqueness for accuracy and what you're trying to do, but that is the key #1 mechanism that we use to train enterprise-level AI. Enterprise-level AI is where you want to control the data. One of the biggest problems that you have with AI is hallucinations, and they're getting very good at it. If you go to ChatGPT and ask a question about something that I'm an expert in, it gives me an answer that I have to think about it to go, that doesn't look right. Wait, that is not right. Because they're very good at lying, extremely good at it. So therefore, you have to be very careful. So the only way that we, from the enterprise point of view, can truly control the data is making sure that that data has been curated to where you want to provide as an answer. So again, this is another view of the retrieval augmented generation. It's where you curate the data, you make sure your data is completely correct, you feed it into this knowledge base, and you're able to query and only provide answers that I curated. We're not writing a document where creativity is important. We're not writing a novel where creativity is important. We are based our success on accuracy to make sure that you have 0 hallucinations and you're able to retrieve and provide the data as accurately as possible. In the last few years, everybody comes to me and said, what about agents? Agents everywhere. Now, remember, go for the enterprise. Agents are automatic processors. They do things automatic without humans. Now, think about the nuclear industry and think about your own implementations. What can you do without a human validating it? Just think about it. You have an agent that doesn't have a human telling another agent to do something without a human validating it. I don't know about you, but that scares me to death. So one of the things that agents are very good is providing insights. You want an agent to do a report automatically, so when you come in the morning, it's already there. You want an agent to be able to do things that give you those insights that you need to do your business. They're excellent for that. But execution agents in enterprise is very dangerous and very difficult. And people like me who are part of the security component of companies are very scared of them because, again, you have no human intervention. They do things by their own. So this is a complete new area that we're looking at, and not because of technology, it's because of the safety and security. So agents are important, but also remember there's a significant amount of security that has to go in place for you to be able to use them effectively. And agents are just what a chatbot is. In other words, a chatbot is where you go and you type and you ask questions and they give you a result, but they do it automatically. So the idea is that you could do everything that you could do by typing, you could do it automatically. So now that I gave you this introduction and maybe everybody now understands how this works, let me introduce what we've done to give you that information, to be able to make all this data available in the digital backbone accessible in a way that makes sense. We introduced this in November of 2026. I'm sorry, November of 2024. And is being used by customers all over the world. This is a little different, sort of a different view. We do not use public available LLMs. We actually take an LLM, an open source LLM. We put it in our own infrastructure. We surround it with a firewall. It's not connected to the internet. It doesn't do reinforced learning. It doesn't record any information that you do. It is completely the most secure enterprise level LLM that we're aware of it. We literally put it in jail to make sure that it only works for you. So if you ask a question, we don't know if you asked a question. It does not learn from you. It only learns from the curated data and from your data. The first thing that we did is provide the authoritative information. In other words, every piece of documentation about our products is in there. You can ask any question, you can ask anything that you want, and it will give you 100% accurate answer and the information about our products. What we're doing next is that we're giving you that same power for your data. Now, why did it take us that long? Very simple. It's very difficult. It's very difficult because the data is customizable. As I said before, you can call it a work order, you can call it an activity report, you can call it whatever. You can call it tomato. And the power of our products is that you can change anything. You can change the menus, you can change the labels on the menu. One version of one product for a customer looks one way, another customer looks completely different. So that flexibility creates problems because LLMs don't know what to do. Remember, we are curating it. We want to make sure that it's accurate. So we came out with a very unique, We came out with a very unique patentable that we're patenting that allows us to actually give you the ability to query directly your data. You can ask any question you want about your data because we're able to interpret your unique nomenclature and convert it to the canonical format of our products. That took some scientific research for us to be able to do this. And I'm very happy to say that we have solved the problem. We're releasing this product of May of this year, and it's going to be the most advanced one in the industry. Now, we will do agents very carefully, very thoughtfully, to make sure that we can keep the trust that you have imparted on us. Something we're very proud of, this level of security that we provide, is that it's your data, only your data, and only you can access your data. And for us to do that, we have to feel comfortable that we're doing everything possible to protect that data. So we will go in that scenario for you to be able to do things, but we're going to do it in a way that allows you to have certainty of what gets executed. As I told you before, this gives you an idea of what we've done. This is all scheduled. This is all curated. We don't do anything outside of our own infrastructure. We don't do reinforced learning. I'm not sure if everybody knows what reinforced learning. If you go to any of the big LLMs and it gives you an error, you can say, no, you made a mistake. This is the right answer. And it learns. That's reinforced learning. We don't allow that. Because imagine if you ask a question and you teach the LLM, and then your competitor asks the same question, and then you get the same answer from you. That's bad. So we don't allow it. We have very extensive guardrail system to protect against bias, to protect against violence. You cannot ask questions that you shouldn't be asking. Again, this is all designed to protect you, to protect your data, to ensure that you're able to, again, feel comfortable and trust in what the AI is giving you. And this is the secret sauce, just to give you a high level of what we're trying to do, is how do you go from this customer-specific terminology to the canonical mapping needed to be able to get the data. To ask anything, we don't know what you're asking. So we could have done it to have specific questions that you can ask. We wanted to give you complete control to ask any questions about your data anywhere. And we're able to tell you that you will have that. Now, the same power that you have by typing and asking the question, you will have through agents. But again, when we're comfortable that we can safeguard the safety of your infrastructure. And this just gives you an idea of a high level we're doing. There's a lot of fancy words here, but trust me, this is good. And what you're able to do is that you will be able to ask general questions like, how do you cook a hot dog? General knowledge. That is the basic training that was trained by the LLM. You can ask, how do you do something in this particular product? That's generic product question. It will ask you, it will give you that. And then you will be able to ask complete information about your data. That's my last slide. And when we started doing this, we set up a design guideline. Our promise to you, our customers, and is that we will do data security, privacy, accuracy, and accessibility across everything we do with AI. And we're very proud to say that we've been able to accomplish that. Thank you very much. Look forward to answering any questions.
And of course, if, yes. Yeah, we can answer that maybe in the networking. So we'll just be right next door. So thank you, everybody, for your attention.